Welcome back to another episode of P5Live Sessions. Tonight we are going to check out random references and give that a try. Once again, we're just going to check out the references. I'll get a new sketch going and basically play roulette with the references using this little surprise guy up here and see where it takes us to do some improvisation. I'll make the code a little bit bigger. So in P5Live, again, there's this references where you can just sort of click a little gift box and see what pops up to learn random things, to look at a random reference. And this is looking at focused, meaning the sketch will accept the mouse or keyboard if focused. So this is a bit tricky. This is about if the sketch is actually the window that's open. I'll write these. I'll write what showed up, but I don't think we're going to look into focused because I'm going to stay in this window the whole time. And kind of the point of focused is leaving the window and coming back to it. But I could always click outside of the window and see what happens if we can get interesting things to mess with that. We're going to go back. We got a couple in audio coming up. Okay, we got Normalize. This is something I never use and probably should. It has to do with vectors. Normalize. And this is an add-on that we can use while playing with vectors. So it looks like you create a vector and then you normalize it, and it brings all those levels down to something between 0 and 1. The question is, out of what? How does it know? How does it know what the max value could be of the vector? Make it unit. I don't know. We'll have to experiment with it. So we have vector normalize. Let's go back and grab another. Trim. A string to be trimmed. Removes white space characters from the beginning and end of a string. Okay, that could be interesting. Trim a string. When do I use that? I think I've used it. Yeah, I mean, you use it once in a while, usually if you're importing data on a form or so, and you want to make sure that somebody didn't add spaces that you don't want. But it'd be interesting, how could we play with that in an interesting visual coded way? We'll see. What else do we have? Touch ended. That would be nice, except I am not using a iPad or anything, or a touch device, so I don't think this will work. But maybe it works even with the mouse. Canvas touch ended, change gray. I guess that's if you click, we'll add it here. Touch ended, but I'm skeptical we'll play with that in a desktop setting. Min value. Okay, that's quite interesting. With gets the lowest number currently stored in the dictionary. My dictionary, I'm never using that, but I should consider it. The dictionary. Create a number dictionary. Interesting. We need something that causes some visual things to happen. We could reverse an array. I have a feeling we'll be playing with type this evening when it says trim and reverse. Whoops. Array, just a plain old array. Okay, we definitely will need an array when we play with reversing arrays. We'll probably have an array of vectors. Maybe we'll have to position type somehow. So this said array. We just have to use arrays. And this is even suggesting return a representation of the vector as a float array. Okay, so this is also attached to a vector. Actually, that's something I'm maybe never doing, is grabbing the array of the vector. So a vector by default is storing 3 values, an x, a y, and a z if you want it to. And then this is somehow grabbing back those 3 values. You could always just grab it with x, y, z, but maybe there's an advantage to having it as an array. This is only for temporary use. So I guess it's often used when you're copying an array. Use the copy method. Okay. Let's check out maybe one more. Square root. square root n. Yeah, that's also something I'm rarely using, calculating the square root of things. Their example is with text. They're doing a calculation. Do they use it in a visual way? I don't think so. Maybe. Let's quickly check out what this function does here. This is all a draw, so let's paste. Okay, it's showing us what the square root is, so yeah, it's just making a small number. I'm gonna undo and go background black to bring it back. I wrote it down, I'm not sure if we'll end up needing it. And reflect. Normalizing this method, reflect an incoming vector about a normal line in 2D. A lot of vector stuff came up. You create a vector and then you reflect it. Okay. I think I'm gonna have to read more about that. We're gonna move square root down here and put this up here. Vector reflect surface normal. This is gonna get some weird math that I don't know if I'm ready to dive into, but we'll see. Let's run this as well and see what this thing is doing. Ah, there we go. Okay. I wonder if it's simply pinging or it's saying reflect. Okay, maybe this is kind of like about, yeah, almost the opposite. So the red one's coming in, hitting this point where my mouse is, and then reflecting off, almost like a billiard cue, I assume. Okay, that's interesting. So there is the original vector, that's 0, 0. It comes to where your mouse is. They draw an arrow there. They create another vector, and then they copy the first one and reflect it. Interesting. Yeah, that's probably kind of fun to play with. Never used. Okay, I think I'm going to undo and bring it back to just our main sketch. Recompile. So we're going to play with a handful of these things. We're going to play with an array, the vector array. We're going to try and reverse them. We're going to try and normalize them. We're going to try and reflect them and somehow mix those up in a visual way. So let's start off with just making a couple vectors. Maybe I need to work with an array of vectors. Is more fun than just a single one. So let's say let v for our vectors. And we could start with a single one. V equals create vector. Where is this thing going to be? I think I'll first put it in the center of the page. And I won't necessarily store a z axis. I'll just store an x and a y, and it's chilling in the center. And then I could do things like, I don't know, let's maybe play with that line example of, maybe I need a few of these things actually. Let's actually say v dot push and push that into it. That should work. So, and maybe I need to tell this to be an array at the beginning. So we'll have a collection of arrays. I'll push, let's start off by pushing something that's like 0, 0 in the upper corner and 1 in the bottom. Make a background and loop through it. I is 0, I is less than v dot length, I plus plus. And maybe I say begin, shape, end, shape, let vec equal v I, and vertex vec dot x, vec dot y. And if I say stroke 255, we should see that line. There we go. All right, let's add another vec. Actually, let's push one that is, let's push one that's the reverse of one of these other ones. So what happens if I say v dot push v one dot reflect. Does that work? Not necessarily. How does reflect work again? What are we supposed to do? Create a vector. Okay, you tell it to n is what? What is n? The normal surface. Okay, so let's say let vtemp equal this vector, and then we'll say vtemp push vtemp dot reflect. I don't know, 5. What does that do? Absolutely nothing. That successfully kills it. Okay, maybe we just, let's add twice our center line, and let's tell one of them to reflect and see what happens. If I say v2 dot reflect 2, that is not how you use this thing. I'm using it wrong. What are you supposed to do? You just say reflect n. N is a created vector. Okay, so it has to be based on another vector. Aha, interesting. That kept it going in the same direction. Whoa, it's strobing out. Strobing out. Okay, let's mess with normalizing the things and see what that's going to do. If I say dot normalize, I'm guessing we have little tiny points up there. So these are now values of 0 to 1. So if I said times width times height interesting. So what happens if I just put a bunch of random values in here and normalize them? For that 0i is less than 5. So now I'm just creating a bunch of random positions, but they're being normalized. And if I don't normalize it, it would be interesting. Let's copy paste this and draw it once without this and turn off this normalize and see where are these things. They are there. So if I turn this off, we see where they normally are. And that's the normalized version. Ooh, that was interesting, seeing both actually. They're just going back to the top. That's not so exciting. Yeah, when and why would I normalize these things? Maybe I should quickly check normalize and see what their example is for normalizing a vector. They had a vector that was 10, 20, and 2. They normalized it, and now they got 0.44, 0.8. Okay, I think I get it. If it's taking somehow a max number, and then it's all becoming relative to that value, maybe, probably not. Let's get one more reference in here just to see point. Points are always interesting. We needed something visual in there, which means maybe I should be playing with point instead of a vertex, and say stroke weight 10, so we can see these points. Okay, let's do one more random reference. Return in a function that's not going to draw anything for us. Release time, that's an audio function. set a value. Another dictionary. Yeah, maybe this random reference has some issues because it's pulling all kinds of references that we don't really need. But this is interesting. Noise detail. Adjust the character and level of detail produced by purling noise. That sounds really fun to play with. Noise is always really interesting, kind of like random, but more organic. And I've never messed with noise detail, which I guess by default noise is computed over 4 octaves, contributing half of its predecessor starting. Okay, maybe we start playing with some noise in addition to these vector points, noise detail, and see what happens as we adjust those things. So I think what I'm going to start off with is like 25 random points. I'm going to turn off fill. We're supposed to play with points, maybe, if we want to. I'm going to get rid of that. I'm going to turn off begin shape, end shape, because we're not really using it, needing it. And I think what would be interesting is we have these points that get positioned somewhere on the page, and then to play with noise in addition to that position. So that's where they're supposed to be, but then you can add some noise to them. And maybe this noise detail ends up doing some nice manipulations in a special kind of way. That's a big stroke point. Smaller. Maybe the size should be based on noise. So I should quickly look at how they're using noise. They're inside of a giant loop. They were doing a stroke that's based on the mouse. I should probably check out what this thing looks like real quick. Maybe we go have a look and then come back to what we're doing. So they already have a setup and a draw. And I will come back to this thing. Make this much bigger, 500 by 500. Okay, this is like, ooh, that's chugging along. Okay, so this noise detail is about how fine and detailed the noise is here. This is a 2D noise, which is really fun to play with for a cloud-like simulation. My mouse X is controlling the level of noise. Ooh, and it's super lagging me out. It is not a fan of this. Ooh, that's a big number. There we go. Okay, at a much smaller size, this is looking better. And, okay, clean this up. What exactly is this noise detail doing? We have a noise value, which is clear. There's 2 different noise details. They're both producing points. If I turn off this point, that was the more detailed side. Turn it back on. If I turn off this one, that's the left side. This is really tiny. It's not so exciting to look at just yet. And this detail, if I turn it off, that's the default of a cloud. But it's interesting, if I turn that thing way down, then we kind of crunch the detail that's in there, obviously. If I put this back at 8, what is this doing? If I put that up at 8, okay, that's sort of a brightness of it. Down to 2, 3. Maybe I try to give us a little bit of space so we can see that thing up there. A 3, a 4, 5, 6. This seems too bright. What happens if I go to 12? I don't see it getting much clearer. They use 6.5 as like a perfect value there. 14, I don't see any difference once I'm going over 12. It seems to get fuzzier. Oops. Okay, and if I keep this at like 4 and I let this value get way higher, I think it just, okay, it gets overblown. Okay, this example here is we can't run it huge because it kind of freaked out when we drew it really big, but maybe it's interesting to play with this example, maybe just one of these noise details, and draw it onto a layer, a graphic, and expand it and see what it's like playing with some of those points. So I'm going to get rid of half of those things. Actually, let's bring it back for a second. It was just X, Y. Okay, this should also be just X, Y. They divided by 2, that's why. So let's get rid of half of this stuff. Not divide by 2, get the whole thing. And let's draw this on a graphic layer. So they had noise scale of 0.2. And what happens if that changes? Ooh, we get tiny scale noise. Yeah, noise is quite fun to play with. Let's grab all this stuff. This should probably be a nice live value in our sketch to live code it smoothly, and noise val is something that it has to hold on to. Okay, I'm gonna steal these bits here from the reference. So let's copy. Let's go back to our other sketch. Let's turn this stuff down for a bit. We'll come back to you. Actually, it's probably easier just continuing from here. Let PG for a P graphic. Let's tell PG to create a graphic that is 100 by 100. So I'm going to draw the thing actually really small, but have our width be really big. And therefore, all of the stuff is going to be based on the pg.width, pg.height. And drawing it on that graphic layer instead of directly on the canvas. This is pg.width. Probably not divided by 2, we'll find out. And I want this to be big again, width, height. Okay, so we're hopefully drawing some pixelated noise on a small canvas that will then make bigger. And I'll say image pg 00. Create graphics. There we go, with the S. And we want to draw this thing huge, width, height. Hey, draw yourself big. Create canvas, width, height. pg.width. That's strange. Why is image not drawing this thing big like we expect it to? What is going on? Image pg 00 width, height, any typo. Graphics. Very strange. PG2. PG2, create graphics. I'll just draw some random shape on it. PG2.ellipse. 50, 50, 50, 50. And if I try to draw PG2, it's still super small. What is going on? X plus Y. Super strange that this thing isn't scaling. I wonder if one of these things is limiting it somehow. Weird, that's one of the fun things to do, is to draw an image quite small and then render it much bigger than you need it. That's what we played with last time when we got into pixel graphics. What am I doing wrong? I think I'm not actually drawing on that thing just yet. Ah, it still thinks the canvas is super small. Ah, I know why. We said window width, window height, width here. This needs to be a window width to be the actual scale of my window. Damn. Window height. All right, now we have large pixelated clouds, which can be interesting to mess with this noise scale here, which kind of messes with like how fuzzy clear those things are. This gets less so. Yeah, so this noise detail is something that we're going to explore and mess with, and I still have to bring text and these other things into it that we pulled out of the grab bag. But first, we're going to see what we can do with this kind of noise detail. And therefore, you just have to change these numbers and see what happens when we tweak these numbers. There, it starts to get sharper and sharper, and it gets up to 12. Okay, yeah, 6.5 seems to be a nice amount to leave it on. It's interesting playing with those things being higher res or lower res. And I think we want to maybe feed a value into this thing to get it to constantly grow, because I think if I say like frame count plus, this needs to be way less, times 1 times 0.1. We constantly change the seed that's going into this noise. So now it's like I can kind of move around and see different views of cloud. Still kind of pixelated. Interesting, that's not seeming to have a big, oh yeah, it does have an effect. Maybe after 7 or so it doesn't really matter. Doesn't seem it. Maybe just to keep the aspect ratio the same, I should do this divided by 10. And do the height divided by 10. So we don't screw up the aspect ratio. Maybe even smaller. Maybe it's interesting that it's more pixelated cloud. You can render it faster. Let's go back to 10. Okay, so that's what happened when we added this frame count here on this value of it. What if we add it to the other value? Then it should go and grow in a vertical way. If we add it to both, then we can get diagonal scrolling. Okay, we're going to play with text and with trim, somehow with taking the spaces out of things. I don't know if that makes a whole lot of sense, but let's see what happens if we swap out some of this, some of these points with type. I wonder if that will just kill the computer if it can't quite handle the type. I wonder what happens if I turn off our point, maybe turn this into a fill instead of a stroke, and say text. Let's just have a single character for now. Let's make like a slash and say XY. Oh, we have to say on PG layer, PG dot. Interesting. It looks the same, but these are actually those dashes. If I say like a R or an O, an X. We're drawing clouds with an X. Maybe we should use a C for cloud. And maybe I should skip a bunch of these. Plus equals 5. Plus equals 5. So that we don't have quite such a high resolution because they were just overlapping each other. Now it looks like there's a camera in there, CCTV. Maybe the text size should be a bit smaller. 5. Maybe we want to, do we want to constantly have a background to clear whatever had been there? Okay, there's just the C's. 15, 5, 10. Maybe I use live type, let myself type out what is here. So I could say str and say that let str equal nothing. And if I press a key, then I can type stuff out. But maybe I tell it just is that key, whatever I just pressed. Then I can change one key at a time. Maybe I'm skipping too many of these letters. Ooh, that's kind of interesting. Control. Command is meta. Space does nothing. Killed it. Backspace looks nice. There's a whole bunch of B's. Backspaces. Let's make the font size smaller. That looks interesting. That's control. That's backspace. If we go even smaller, backspace, control, meta, G, H. Maybe I don't need to skip quite so many of these things. Let's do skip by 4 to get it a little bit more full. Where and how are we going to trim stuff? Back I had this plus, I guess space kind of was interesting. I guess we don't see anything when it's so many characters. Then it has to be a really small type. Yeah, I'm curious if this really made such a difference. Making this noise detail. When I go back to just points vision, back to stroke. Oh yeah, we're skipping a whole bunch. Plus equals 1, 1. If I turn off the noise detail, okay, it makes a change, but actually it's kind of nice without setting the detail. We get softer cloud. No, it's more detailed, more defined. I think it's useful to have that when making clouds, but I don't know if and how it makes sense to bring into the vectors. We played with clouds and type. Maybe we come back to our vectors and mess with noise here. Because if I were to apply noise to these things and say, hey, be where you are plus noise, something needs to come in and move it. So like frame count times 0.1 times 10 or 100. We'll kind of wiggle those things around, but together. Then I could say I times 4 plus. So they're on their own rhythms moving around. Faster or slower. Let's also let them move in another location. Now it's kind of those points where they're supposed to be but dancing. Maybe this offset amount should be a variable, let offset equal 100 so that I could change my mind easily. And let's try the noise detail and see if that makes a difference here, but I don't think we would see it in this situation. Noise detail 4.5. Do we see the difference here? Probably not. I do see a difference. It calmed down. If I go back to 9, it's more wiggly. Versus 3. Maybe we leave a trace and see what exactly are they doing. They're making interesting little squirrels. It kind of looks like they're writing something for us. Make it smaller, let them leave a trace. Maybe I should let their offset get bigger so that they could leave a longer trace on the page. And I should see the difference of when this thing was at 12. Do they leave a different kind of trace? They do. These things are now moving way too fast. They have a lot of wiggle in them. Maybe because their detail is so high. 8 is still quite a bit. Yeah, 3 was kind of nice. They had this little like pause to them. What is happening when I change this value instead? They seem to be consistently moving rather than before they were taking like a little breath. Whoa. Interesting. This is scatter shotting those points. That's also kind of interesting. To create kind of a noise on the spots. Could be interesting to draw that same point twice and do it once with sort of a thicker marker and once with a really light marker. So if I go back and let this thing, what was it? It was at 8 or 9, but put the stroke weight to be way small. Then we slowly build up a texture. In different areas of the screen. I think I want to see this line twice with another detail. Hopefully it can do it just twice on each of those. Yep, it can, but they're in different spots. Bummer. It puts them totally different areas. Yeah, this quickly looks like we're drawing on an old, maybe like an early black and white Mac. Black and white, some kind of Paint Shop Pro or so. Or Paint, I think this was probably Paint. And maybe I need more of these things. They're leaving up a nice pattern already. I'm just going to save a picture and see what that looks like later. And let's let there be more of these things and just let them go nuts all over the page. This might be nice to use as a texture on some other shape. Maybe it's interesting to draw these things on multiple layers, to have a whole bunch of layers. We've got 20 minutes left to draw one of these things per a layer, just kind of making its form. And if we have a bunch of these things, then we could kind of play going through them and see what they look like adding up on top of each other. if this wasn't a point, but actually an ellipse that was a bit bigger. Maybe with no stroke. Whoops, no stroke. But here we have to have stroke back on. Stroke 255. That's kind of the same thing, doesn't make a big difference. Oh, big circle is probably too big. This 15 was interesting. Worms running around, but kind of weird organic squiggles. Maybe the stroke should be even more opaque, translucent. Maybe this needs to be a slightly different color just to give some texture, have that splatter be producing a bit of color back there. Yeah, I don't know yet about the background if that's really doing a whole lot, but these forms are quite cool in the front. So I think those should also maybe use some noise to get bigger and smaller. Maybe I just start off by stealing this little snippet here and tell this thing it's allowed to get bigger and smaller and let it get way bigger. And start it over and see what that looks like. These things get bigger and smaller. It would also be nice to see these things in more 3-dimension. To see them at different depths. If I turn off the noise or the background dots for a bit just to check out what they're doing, let them get bigger. Yeah, they look less like handwriting now, and now some kind of static skeletal structure. Let me mess again with this value for how fast these things move. From something too excited, moving too much around, to the opposite 0.0, where they just barely have a movement. And what was it like when they were told not to wiggle very far from each other? Some kind of organs. What happens if I bring back normalizing? We took this away a while ago. And I believe if I just take this away, they're all going to draw right in the center. So if I say translate to the center, where they're all drawing up in the corner, then I could do something like multiply these things by 150, 550, yeah, I'm not so sure I need to normalize these things. I'm sure there's a great use case out there for when one would normalize, but I don't really think that this is it. Let's see if I can still get that effect while being in 3D with this opacity. It leaves something different, a different kind of trace. All this stuff is going to work a bit different in WebGL with this 3D on. Maybe we need to give this a little bit more opacity. But then what's interesting is we can position these things in different three-dimensional space. With the background on, just kind of see these things blobbing back and forth. Maybe we should be using the noise again with their stroke. That was a thing back a while ago, or part of the other sketch was doing noise of things changing. Frame count times 01 times 255. And we want to use I in there somehow to make them each unique from each other. So some of them are going to be at different speeds than others, getting up to 255. Maybe we bring back full opacity with these things. And I definitely want to put these things in a 3D space, so let's do translate. And move this whole thing to the translate. And try putting them in kind of a Z-axis noise. So I could make this thing a little prettier by saying that is my X. Whoops, missing something. That is my X. Let Y equal this one. And do the same for Z. And just see what that looks like in depth. We're in 3D space, so we should do a quick rotation and see. Rotate Y, radians, frame count, just to see what these things look like. I want to be careful of turning this into some 3D spinning tracing thing, which I'm a fan of. They're not quite going as far back into the forward, the front and back as I would like. Maybe they shouldn't be spinning all around the world. Maybe they should just be spinning in place wherever they got settled. So then those things spin around in their own place. They're a little bit like points, but not really. If we make fewer of them, 25 of them, put the noise detail back up to some other level and see what happens when they wiggle in a different way. Speckle. No speckle. Let's turn that shape back on and see what happens when we show those points where they were connected to without the noise attached. What happens when we still use this as a point? So these are as ellipses. Let's copy paste, disable one, turn it into a vertex. It doesn't use translate, so it actually has to use XYZ as its values. This one is definitely moving too slow in the forward and back movement. And where's our stroke? This thing should be going... the whole thing goes as one big shape when it's a vertex. We don't have separate lines, actually. Yeah, that's not as exciting to play with the actual line. So maybe I turn off the vertex and use lines. 0, 0, 0 to X, Y, Z. Let it connect a line from where it's supposed to be to somewhere off in the distance where its untranslated value is. And then they each get to have their different strokes, which was happening here, which could change rapidly. Their movements could slow down. Maybe this one also should slow down. Leaving silver pencil shavings out there. Yeah, this is almost like back at that cloud view, but sliced down to one pixel, one elongated pixel, now as a line. Maybe I just try another rotation and see what that looks like. Let them change on an X value. Or maybe they need multiple values. Oh, it's rotating pretty fast. Yeah, now by having this be a tiny number, they are way more in sync with each other instead of being far off one another. Some of them are still moving way too fast. I think you could slow the whole thing down so it leaves more of a trace instead of accidentally leaving these like clear lines. Maybe it's interesting to use normalize here in a certain way. Instead of telling it to go off to each of those places, maybe I say let vtemp equal vec dot normalize, if that's a thing. And then I could say vtech.x, vtech.y, vtech.z. And now they're just like little points hanging out there, but then I could make how far away these things are from each other. So maybe I actually just use that offset times offset and see what happens. Maybe it builds the exact same thing I had before, but I don't think so. These things should be bigger, and it's still a question what the right kind of rotation is that makes the most sense for leaving a trace. I think offset's not big enough. We need something else. Let norm off equal height divided by 2. Use that everywhere. Let's let this thing flip once super slow in a vertical direction to leave a slightly different trace. There might also just be too many of these things. Let's test out taking a bunch of them away. Maybe even fewer, just what's like with a couple of these things. And quickly testing again what it's like without a background when they're just actually those lines floating in space. Now it's kind of like these floating needles. It's kind of nice. Let me put a bunch of them again. We don't always have to leave a trace, although it's super fun leaving a trace and seeing what's happening. Can push it and have a bunch of these things. So there's a problem that they're all gathering up at the top there. I don't think that's just from the rotate. I think some of them need to be allowed to get further or lower. Let's give ourselves the ability to spin around the thing. Okay, there we can see how they're kind of collapsed, and that might be, is it possible it's the z-axis? I think so. So we should probably be letting this thing get a positive and a negative. That can expand in front and behind, but like super slow. Turn off the background. See what it traces out. It turned into a screensaver, a metallic version of an early screensaver. I think we might have lost it a while ago. It's just something else now. We've got one line just chilling, going super slow from bottom up. And it's probably worth seeing the things as points again, just to test what a point is like. Let me copy this and just say, let's have a point at 0, 0, 0. Turn that off. It's just tracing these points around. And then we could also have a point where the other end was. And it'll be kind of the same thing. But it ends up showing us, I guess, where all those lines were kind of clustered in the center. And now the other end is making a crazy wreath around that. If I spin some degrees, we can see this cluster in the center. It's making a super nice pattern on the outside there. Which ones are those? I think those are those ones. Interesting. There we go. The normalized ones being told go off a certain direction end up creating this wild bundle of cable or wires that unfortunately are not keeping track of all those positions, so it's not like an actual thing that we could spin around. All we can do is let it render and build this bird's nest, we could say, or cable salad, and wait for it. Let it build it up. Hey, but that's nice seeing that Normalize. No idea what I was doing something weird. I'll have to keep exploring exactly what that was doing, and why it was so different than the original point, but the way that that created an interesting tweak to our vectors and sent them on this fun path. It's creating quite an interesting shape. It's top down of a slipper or a nest. Let's save and twist it one more time and let it build it up in some other rotation. Hard to tell what that should be. Maybe I changed it. Maybe I turn off this X and put it on a Y. I think it's a metaphor for all the cables that are sitting to the side of the desk here, running all over the place. Home office. These are our living rooms now with cables. I like it. It's an interesting bird's nest or some kind of a woven structure. We got lucky there, turning off all this stuff, turning on a point, turning off one of the points. Then it just makes, kind of an unexpected form. I would have never thought of making this or known really how to do it. Putting these things in a circular path. I think the next step would be playing with it and keeping track of a lot of those positions and sort of throwing them into an array. I don't know how many you could actually store. But it would be interesting to see how many of these you could hold on to so that you could spin around this thing. And then you export it as an object and 3D print it and have a crazy mess of melted plastic. But that was interesting just a second ago, this twist and spiral. Putting something in the center of it, filling it in. I think that's because this thing is spinning around in a Y rotation, but it's so slow that we don't really notice the spinning. It's just kind of sending all of these threads off to one of those sides. Hope it's not too pixelated out there in internet streaming land. Hope you enjoyed watching clouds turn to type and then screensaver building and then nest building. Hope you'll join next week where we do some further improv and see where it goes. Thanks for watching.